Okay, so hello everyone. The question which we will be solving today is minimum operations to make binary array elements equal to 1. This is the equal to 1 part 1. Okay, this is something like let me just show it. Okay, so this is the part 1. So as you can see, the question number is 319, right? This is the question. Okay, so, and it is marked as medium, right? Okay, so now let's just read the description and try to solve it. Okay. So you are given a binary array nums. Right? Okay. So what is a binary array? Binary array is an array in which the elements will be either 0 or 1. Right. You can do the following operations on the array any number of times, possibly 0. So we need to perform some operations on it. Okay. It might be that we don't have to perform operations like we can, the requirement doesn't need that you have to perform the operations on this. So what is the operation? We can see it. Choose any three consecutive elements. Okay, we need to choose any three consecutive elements from the array and flip all of them. Okay, flipping an element means changing its value 0 to 1 and from 1 to 0. Okay, so suppose 0 0 0 1 and 0. Something is like this is here. So suppose you choose these three elements, it will become 1 1 1 and this will become 1 0, right? Okay. And suppose like okay, so suppose like if you choose these three elements and try to flip them, so it will become 1 0 0 0 and we will have 0 1, right? So suppose if you now like choose these three elements, so it will become 1 0 1 1 1 and then we will just it will be 1, right? And suppose if you choose these things, so this will become 1 0 1 0 0 0. Okay, so now you mean what does the flipping means? So let me just clear this. Okay, let me just so yeah, just so this is it. So return minimum number of operations required to make all elements in nums equal to 1. If it's impossible, return answer. Okay, so what is given? Right. Okay, let me just write it in a simpler way. Okay, an array nums will be given. Okay, it's a binary array. Binary array. We need to perform operations on operations on three consecutive elements such that the array becomes one. One. Okay. One array, which means all elements elements equal to, right? And we need to return number of operations. Okay. And like, if elements are not like all the elements, like all elements not equal to 1, return minus 1, right? So this is the question, right? So uh, let's just take this example and try to solve. So what is given? Just write it. So what is given? 0, 1, 1, 0, 0. So okay, so something like this is 0. Okay, this is the index. So what do we need to do? Like we need to like choose any three consecutive elements, right? Okay, so let's just take three pointers which will be pointing at three consecutive elements, which will be I, J, and K. Can we take it? Right? Okay. Okay. Suppose I is here, J is here, and K is here. Right? So at index I, we can see that there is like a zero element. So okay. So let's just flip it. Let's just flip it. So the array, it will become something like this. Like 1, comma 0, comma 0, comma 1, comma 0, comma 0, right? 0. And we just move the ijk, right? ijk, right? So now we are here. It is again 0. So like you can just flip it, right? So I think I should be writing it in a place that it can be like easily. I can write all the operations. Okay. Let me just move it. Let me just move it. Okay. Can move it to this one. Okay. So I is here, right? So okay. So this is our operation. Here was my operation. Operation. Can we say one? Yeah. Here is also you can see this is so and here will be our operation 2, right? So what it will become? It will become 1, 1. Okay, see, we are performing operation with for the all these three consecutive elements, right? Because flipping means that, right? So suppose now we flip it, right? So flipping it will give us 1, 0, and this will become 1, and this will become 0, and this these are the 0. So 0, so what will be indexing 0, 1, 2, 3, 4, 5. We move I, so I will become like I will become I. Okay. Okay. So now see that I is 1, right? And J is 0 and K is 0. Okay. So tell me one thing that should we flip according to J? Tell me this thing. See, we are moving forward, right? We are moving we won't be coming back. Suppose we flip this or flip this. Are we going to come back? No, right? But like on the basis of this, should we be flipping this window? I don't think that's a great decision, because suppose we flip it, we will be moving I here, right? So will we be able? This will become zero, right? So will we be ever able to come back again? No. So can we say that we are going to flip only according to? Okay. So can we say that we are going to flip only according to I, right? This will be no. We will only be flipping according to I, right? So here we don't need to flip, right? Okay. So we move the I, right? So the array, what is your array? This is 0, 0, 0, 0, and 0, 1, 2, 3, 4, and 5. I comes here, J comes here, and K comes here, right? Okay. So we can the I is 0. So what do we need to do? We need to flip. So this will be a operation third, right? So this will become 1 comma 1 comma 1 comma 1 comma 1 4. So 0 2 3 4 and 5. And as soon as we flip it and move the I, J and K, it will become out of count. So how many operations did we take? Did we took like uh, 1, 2 and 3? So can we say that 3 is our answer? Can we say it? Right? Because we needed 3 operations. But should we be returning it? No. Before returning it, we should be checking, right, that if all the values are 0 or not. Sorry, all the values are 1 or not. So one iteration we will be checking if any value is 0, return minus 1. Yeah, this will work. This will work. You should be doing the try run of it, and this will work, right? What else example? Okay, so let's just take this example. Right? Let me just, it was like what? 0, comma 1, comma 1, comma 1. Right? It will be like 0, 1, 2, and 3. Okay. Starting from here, I, J, and K. Right? Okay. So I is 0, flip it, operations becomes 1. Right? After flipping it, what it will become? Like 1, 0, 0. I am 0. Right? So I is again 0. What do we do? We increase the operation becomes 2. So it becomes 1, comma 1, comma 1, 0, 2, 3. And we move the pointers I, J, and K. K becomes out of bound. Out of bound. Right? If this is out of bound, we have operation equals to 2. So suppose without checking, right, the array is something like this. like this. It's without checking if all elements are 0. Now, if we return, if we would have simply returned the this operations was equal to 2, so the answer would be wrong. In this case, we found a 0, so we return -1, right? Yes, and as you can see, we should it is -1. And in the explanation part, it's written that it is impossible to make all elements equal to 1. It's impossible. So yeah, that's the code for it, and let me just show you the. I mean, that's the explanation for it, and let me just show you the code for it, right? So as you can see, we have calculated the num size, so to just rotate it. We have I, J, and K vectors. I, J, and K. They are one is step ahead of each other. 0, 1, right? And the count is 0, right? If nums of I equal to 0, what we are doing now. So I is equal to so, so what does this means? That this means that whatever it is, see, nums of I is equal to 0, so we know that this will be 1, right? And whatever in these two parts, right, J and K, it will be something like this. If it's 1, it will become 0, and if it's 0, it will become 1, and if it's 1, it will become 0, right? So this is what we are doing, and we are just increasing the count plus plus, which we was writing as operations over here. Okay, operations, right? And at the end, we are just on the I, J, and K. And we are only checking it to K as SL because I and J will never cross K, and K will be the last, like the first one to get out of boundary. And at last, we are checking if any of the element is equal to 0, we are just returning -1. Else, we are returning the count, right? So yeah, that's the code for it. And as you can see, the code is running fine. Okay. Talking about the time complexity, see, time complexity must be known, right? Time complexity is must be so the time complexity is like we are just repeating it once. So time complexity would be. And talking about the space like we aren't using, we are just using like 1, 2, 3, 5 variables. So yes, you can see we go constant space. 5 variables. We can also use like lesser variables, but it's fine. Code needs to be easy to read, easy easy to read and understand. So the, the code link and the question link will be in the description box. Okay. So there you can check out both of them. Okay, yeah. So that's all for this question, and have a nice day.